Welcome back. Today we're going to be talking about partitioning a line segment. So this is an extension to Chapter 1. It wasn't included in the original Chapter 1 notes packet, but I did give you a copy of the PDF that you can download if you'd like to take notes on that. So today we're going to be talking about how can line segments be partitioned? How do we find the point of a directed line segment that partitions the segment in a given ratio? So this first diagram here, we have segment AB, and then we have a point P, and it tells us that point P divides AB in the ratio 3:1. What does this mean? And prove it. So what this means is that the distance from A to P is going to be 3 times the distance from P to B. And how you can prove that is if you were to actually measure this with a ruler. This is about 2.25 inches, and this is about 0.75 inches. So if you were to multiply 0.75 times 3, you get 2.25. So the distance of AP is 3 times the distance of PB. So I'm just going to make a quick note. So distance of AP, 3 times distance of PB. Okay, so moving on, do you expect point P to be closer to A or closer to B? So because this is a 3:1 ratio, that basically means that point P is going to be 3/4 of the distance from A to B. So that would mean that P is going to have to be closer to B because the distance of AP is much greater than the distance of PB. So let's go ahead and write that out. So distance AP 3 times distance PB, as we said earlier. So P, oops, and that's supposed to be a B, sorry about that. So P is closer to B. How does the slope of AP compare with the slope of AB? Why? So the slope of AP and the slope of AB are going to be the same because they're on the same line. So they have to be equal because they're collinear. So if they're on the same line, they have to have the same slope. Okay, so up next, find the coordinate of point P that lies along the directed line segment from A 3:4 to B 6:10 and partitions in a ratio of 3:2. So, a couple things to keep in mind. So a directed line segment means the line segment has a direct association with it, usually specified by moving from one endpoint to the other. It tells us the direction in which the points we start at and end at. So in this case, point A to B. So therefore, point A has to be x1, y1, and point B has to be x2, y2. What does this tell you about the distance AP and PB in relation to AB? So in this case, AP is going to have to be, sorry, my pen just went out, AP over AB has to equal 3:2. So it's in a 3:2 ratio. So the distance of AP over the distance of AB would have to be 3/2 if you reduced it. Okay? So then what we're going to do is we're going to go through and actually solve this. So there's quite a few steps, but I have them outlined for you. And we're going to take this first one nice and slow. So first they want to label your points. So that is already labeled for you in the diagram, but we're just going to go ahead and put that on this paper so we have it. So we have A is x1, comma, y1, which is 3, comma, 4. And then we have B is going to be x2, y2, which is 6, comma, 10. And I'm just pulling that directly from the diagram or the instructions. So then from there, step 2, and I'm going to label my steps, that's step 1. Step 2 is convert the ratio into a percent to keep as a fraction. So we need to get this ratio in fractional form. So they tell you that if it's in the form A to B as a ratio, like we have, the formula to figure out the ratio is A over A plus B. So we have A over A plus B. So our A, in this case, our ratio here is 3 to 2, right? And that's our A to B. So if we plug in A, that's 3. If we plug in A plus B, that's 3 plus 2. So we have 3/5 is going to be our ratio. Okay, step 3, find the rise and run for this segment. Order does matter. Sorry, order does matter. So because A is our x1, y1, and B is our x2, y2, we're going to have to figure out what the difference is. And just to give you a visual, since this is kind of sort of plotted for you accurately, we're looking at the change in y, so that's this vertical change here, and the change in x. Okay, so if I were to do this, it tells us exactly what to do. So first we're going to look at the rise. So the rise change is y2 minus y1, which in our case is, our y2 is 10, minus our y1 is 4. So our rise difference is 6. Okay, our run difference is x2 minus x1. Remember, I'm just getting my coordinates from step 1. I have them all labeled. So x2 is 6, and x1 is 3, which is 3. Okay? There's step 3. Then we have our last step, which is step 4. So we have to figure out what is the partitioning point. So where would that point P be that's way up here? That's already labeled for us. So what we're going to need to do is for our x coordinate, I'm just going to abbreviate, that's for x coordinate, we're going to take our x1 plus our run times our ratio, which we found was 3/5. So our x1 is 3 plus our run, which we found in step 3, was 6 times 3/5. So then you would go through and simplify that, and you can keep it either as a fraction or you can convert it to a decimal form, whatever you prefer. So if we go ahead and simplify that, and whoops, I'm so sorry, I messed up. I just saw something that I messed up on, so let me get that real quick. This right here, I picked the wrong number, sorry. So I'm looking for run, not rise. And my run was over here. So my run was 3. So I need to use that 3. So let's go back and change that. Okay, now we're fine. So now we're going to add 3 plus 3 times 3/5, which is 3 plus 9/5. And that comes out to 24/5, which if you write that as a decimal, that's 4.8. Okay, then we're going to find our y coordinate. So our y coordinate is y1 plus our rise times 3/5. So I'm going to make sure I use the right number this time. So our y1 we can get back from step 1, it's 4, plus our rise, which is 6, times 3/5. Then you just go through and you simplify that. So when I simplify that, that's going to come out to 38/5 or 7.6. So my answer to this question would be that P is at 4.8 and 7.6. Okay, so then it asks you, how could you use the distance formula to check that P partitions AB in a ratio of 3:2? So without actually doing it, we could find the distance from A to P, and we now know that this coordinate is 4.8 and 7.6. So we'd use our good old square root parentheses x2 minus x1 squared plus y2 minus y1 squared all under a square root, and we would solve. And I won't take you through that because that's not the lesson today, and I don't want to make this video super long. But if you did solve that, you end up getting 9/5 for that distance. And then let me change, I guess it won't let me change it for just one part. Okay, bummer. And then for the other distance for PB, if you solve that using the distance formula, you end up getting 6/5. So if we come back over here to where we were looking at the ratio of the distances should be 3/2. So the distance from A to P is 9/5. And then the distance from P to B, I'm sorry, that should have been PB, my bad, is 6/5. So if you simplify that, this is like dividing fractions with keep, change, flip. So you'd keep the 9/5, you'd change it to multiplication, and you'd flip that second fraction. So what would happen is the 5's cancel, and you're left with 9/6, which reduces to 3/2. So that's how you could check using the distance formula. I'm not going to make you do that during this section because this is already a ton of work, and we already covered distance formula, but just so you know if you ever wanted to check on an assessment. Okay, that's it on that page. So let's continue on to the next page, and I'm going to switch back to blue. So we've got 3 more examples we're going to do together, just following that same procedure. So this time we have the coordinates 1, 1, and 7, 3, and we're looking for a ratio of 1:4. So the first thing that's always a good idea to do is just label your x1, y1, and your x2, y2. Okay? Then we can follow the same steps we did above. So our next step was we figured out what is the fraction. So we need to convert that ratio into a fraction. So 1:4 is going to be equal to A over A plus B. So it's 1/5. That's our ratio we're using. Then we find the change in x. I'm going to do x first this time, which is our run. So to do that, we take x2 minus x1. So that would be 3 minus 1, which is 2. And then we find our change in y, or the rise. And that is y2 minus y1, which is, oops, I'm sorry, I messed this up already. The run, I did the wrong coordinate, is 7 minus 1, which is 6. Sorry about that, guys. And then the rise is your y, 3 minus 1, which is 2. So as you can see, very easy to make little mistakes, so always kind of check yourself as you go. Okay, that's corrected. So then from there, we find our x coordinate. So remember to find that it's x1 plus your run times your ratio, which is 1/5 in this case. So my x1 coordinate is 1 plus my run, which is 6, times 1/5. So that's 1 plus 6/5, which is 11/5. Okay, then I'm going to find my y coordinate. So that's your y1 plus 1/5, our ratio, times our rise. So our y1 is also 1. So it's 1 plus 1/5 times 3, so 1 plus 3/5. And that comes out to, oops, I'm sorry, I think I got the wrong number. Sorry, that was 2. Gosh, guys, I'm sorry, I am not with it today. So 2 is our rise number. So 1 plus 1/5 is going to be 7/5. 1 plus 1/5 times 2 is 7/5. Okay, so then I have my coordinates. So my final answer here would be 11/5 and 7/5, which is 2.2 and 1.4. And you can leave it as a fraction or decimal. I would take either answer. So that's example 1. Let's try example 2. So this time we have the coordinates -3, -2, and 6, 1. And we're trying to split into a ratio of 2 to 1. So let's list our x1, y1. So that is -3, -2. And then our x2, y2 is 6, 1. Okay. So then from there, we need to convert our ratio to a fraction. So 2 to 1 is going to equal 2 over 2 plus 1. So 2/3 is what we're going to be working with. So then I'm going to find my change in x, or my run. I'm going to make sure I do it correctly this time. So that's x2 minus x1, which would be 6 minus 3, which is 9. Then I'm going to find my change in y, or my rise. And to do that, I'm taking y2 minus y1. So that's 1 minus 2, which is 3. Okay. I think I did it correctly that time. All right. So then we're going to find our x coordinate. So we have x1 plus our ratio times our run. So our x1 is -3 plus 2/3 times our run is 9. Then if we go through and simplify that, that comes out to -3 plus 6, which is +3. Nice, we get an actual number and not a decimal this time. And then our y coordinate is y1 plus 2/3 times our rise, which was 3. Okay, our y1 was -2 plus 2/3 times 3. So that's going to be -2 plus 2, which is 0. So my answer would be 3 and 0. That was a nice one. We actually got whole numbers that time. Okay, example 3. Find the coordinates of point P that lies along the directed line segment from M to N and partitions the segment into a ratio of 3 to 2. So instead, I'm going to just go ahead and put down 3/5 because I want you to get practice if they give you the fraction to start out with of how you do it. Some of the ones on your test might be that way. So if they just say split this into like, hold on, how would they word it? They'd say find 3/5 of the segment M to N. Find the point that's 3/5 of the way. So we're going to do it that way just for practice. It's the same problem, whether it's the ratio or the fraction, but I just want you to know what you do if they already give you the fraction. So if they already give you the ratio, then you don't have to do any of that work of doing the a over a plus b. You just use that fraction. So it takes a step away from you, which is awesome. So let's still go ahead and write down our x1 and y1, x2, y2. So it does say from m to n, so we need to go in that order. So -3 would be our x1, y1. And then 4, 2 would be our y1. Sorry, gosh, what am I doing? X2, y2. Sorry, guys, it's been a long day. Okay. Our ratio, they already gave us, so we don't have to do that work. Our ratio is 3/5. So then it's just going to be exactly what we've been doing. So we got to find the change in x, or the run. So remember, that is subtracting your x coordinates, x2 minus x1. I won't write it out this time. So that's 2 minus 3. No, that's 4, sorry. So sorry, guys. Getting my x's and y's backwards a lot today. Okay. 4 minus 3. So when you subtract that, that's 7. We have a plus plus. Then our change in y, or our rise, is our y2 minus y1. So that's the 2 minus 3. So that comes out to 5. Okay, so then we're going to find our coordinates. So our x coordinate is our x1 plus our ratio, which is 3/5, times our run. So our x1 is -3 plus 3/5 times 7. So if you go ahead and multiply that out on a calculator, it comes out to 6/5. Okay, our y coordinate is our y1 plus 3/5 times rise. So our y1 would be -3 plus 3/5 times 5. So then if I simplify that, that just ends up being -3 plus 3, which is 0. So we have 6/5, 0. And if you want to convert it to a decimal, it's 1.20. And then let's go ahead and plot that point. So it would be like right about there. So it does look like it falls on the line, which is a great sign. It means we did it correctly. So that's it for today. Thank you for watching. We'll see you next time.